Hey everybody, welcome to Python 4305. This is Team 1's presentation. I am Zachary Scott Friend, the project manager for this assignment, and we are going to begin our presentation. So buckle in and listen up. So to begin our overview, we're going to discuss all of these points listed here. We're going to start with our introduction, continue on to our first continuous data set, which covered traffic patterns. We're going to discuss k-mean clustering, multiple linear regression, and then we're going to jump over to our categorical football data set. And with that one, the algorithms we applied were the k-nearest neighbor and the naive Bayes. Then we will discuss our results in depth and then finish up with a conclusion.
So for the introduction, we're going to discuss machine learning. Machine learning is an artificial intelligence and computer science which focuses on the use of data and algorithms to imitate the way humans learn, gradually improving its accuracy. So why do we use this? Because we can use it to predict and aid in decision making, and it helps us reduce large data sets into manageable and readable models. And what are we using it for today? We're going to look at links between different variables in our continuous data set and how they relate to each other. And then we're going to also use it to predict the correlation between the variables in our categorical data set.
Our continuous data set that we obtain from Mendeley Data, it's a free cloud-based communal repository website. It is a distribution data set for a fuzzy-based fog load balancer in a traffic light setting. It consists of 104 observations with 5 columns, including one dependent variable, which is our y, and 4 independent variables, x1, x2, x3, and x4. Our dependent variable, it is the link health across the system, and our independent variables are the traffic load, delay sensitivity, energy consumption, and link saturation. The compiling of this dataset helps highlight and understand the effect of those 4 parameters on the health of a link within a fog computing. All the variables are mapped to term using a fuzzy logic, defined as a form of many value logic. The truth values of variables may be any real number between 0 and 1, and it is used to handle the degrees of truth rather than the usual true or false, 1 or 0 Boolean logic.
So the following table shows the fuzzy terms mapped for different scenarios. This data set was used to simulate a fuzzy base load balancer, and distributions were used to create realistic enough data. The 4 independent variables that are used as parameters and the dependent variable that is deduced from those variables have values that were generated based on random variable distributions created through a few built-in random Python functions. This data set is used to devise a three-level load balancer, and it consists of 3,000 records, where each subparameter or subvariable corresponds to 1,000 records for a three-level fuzzy load balancer design. For example, for the parameter traffic load, subvariables are the minimum load, the average load, and the peak load. So the data set consists of about 1,000 records computed using the random distribution of peak load, thus resulting in a total of 3,000 records for traffic load. This division is computed to cover maximum different possible scenarios to which the network traffic load belongs to. The link health is then computed from those variables.
All right, so one of the machine learning algorithms that we used was k-mean clustering, which is a popular unsupervised machine learning algorithm. Unsupervised means that instead of looking at the result, the y variables, we look at the x variables only and look at their relation to each other. What we mean to do here is that we want to look at our large cluster of data based on those three attributes. We have to use a 3D plot because we have three attributes. And then we want to distinguish those into a number of K clusters or K groups to see if we can see if that there are obvious groups in the cluster of data. So we do this by pruning and rescaling it to where there's no mean or unit variance. I used the elbow method to basically look at the within cluster sum of squares distance between the points and the centroids. After doing that, I encoded the attributes into, or I encoded each point into three separate groups. And then from those three separate groups, I was able to graph, this cluster of data, distinguish it into three clusters based on our elbow method, and then graph the centroids of that, of those clusters. Next slide. From this, comparing the three centroids to each other of the three clusters that we were able to find in our data, we came up with a silhouette score. So a silhouette from our silhouette analysis that basically measures the goodness of fit of our clustering technique. We had a score of 0.26 approximately. The range is -1 to 1. So as long as it's not negative, we know that the data is arranged correctly. And it's above 0, which means that the data represents what you would find in real life. However, 0.26 is still significantly below 1, which means that while it can represent what you'd find in real life of our continuous data set, it's not considered a strong representation of what you'd find in a real life scenario.
All right, so the next algorithm we used was the multiple linear regression. This is a supervised machine learning algorithm. It is used to predict a continuous output variable of y based on its behavioral on the variables x. So from this, the MLR allows for multiple trends to be quantified and observed, as well as fitting the plot points with appropriate linear trend. Multiple linear helps to observe how multiple variables interact and affect the continuous y output. Yields many help metric for set what yields many helpful metrics for a set, which is mean squared error, the root mean squared error, and the r squared value. As you can see on our graph, we have our data set that produced a nice trend line. This multiple linear algorithm computed an MAE value of 0.25 and an RMSE value of 0.28. The values being so low can indicate that with high accuracy, we can predict how the link health as seen in the figure. Multiple linear regression algorithm perform better in terms of predicting a more accurate representation of our data.
All right, so the next data set that we went over in comparison to the continuous data set was our categorical data set. The categorical data set, which we observed, was a fantasy football data set. It was obtained from FF Today, which is an online fantasy football community. The data set we used was extracted from one of the website's large databases of running back player statistics as of 2022. The data set is composed of one dependent variable, which we called Y, which is the football conferences of the players under observation belonging to three independent variables defined as X1, X2, and X3. These independent variables represent the players' statistics. The statistics of the players that are being looked at here are namely their number of attempts, their yardage, which is the number of yards the player manages to move the ball forward towards their opponent's end zone, as well as their overall number of touchdowns. So in this exercise, the variables are manipulated and compared to observe the correlations between the conferences the players belong to and their statistics. By doing this, we hope to discover whether one of the conferences gathers better players than the other. This would demonstrate their statistics. The conferences which we looked at are the National Football Conference, or the NFC, and the American Football Conference, or the AFC. In this study, which players are better is designated by their number of attempts. A number of attempts is X1, as well as their yards, which is X2, and their total touchdowns, which is X3. Although only the players and their team names are listed in the data sets and not the conferences they belong to, Bayes code is used to predict whether the players will belong to the AFC, the American Football Conference, or the NFC, the National Football Conference, based upon their statistics. So a total of 100 observations was collected from FF Today's databases in order to execute this particular study.
Awesome. The first model that we applied to our categorical data set was K-nearest neighbor. KNN is a widely supported supervised learning algorithm used for classifying data or forming regression trends. For this KNN to be applied to our data set, the gathered set must be properly proportioned and reshaped into test and different training sets. The categorical data for this set was also broken up into a binary selection, 0 or 1, for AFC or NFC to increase our sorting capabilities. The value statistics outputted from KNN include accuracy, precision, recall, and an F1 score. As for our next model, it was naive Bayes that we applied to our categorical data system. Another well-known supervised learning algorithm, just like KNN, used to specifically classify our data set. To correctly prepare the incoming data for naive Bayes study, the set must also be reformatted to convert all categorical variables into numerical variables. This data must then be split into groupings of test and training sets, as well as being shaped into arrays for processing. The optimal model for a naive Bayes study is determined by using cross-validation, which is exactly what we did.
Alrighty. So comparing the two models with our categorical data set, of course, they were both used for a categorical model of the running player stats in both of the conferences. So using their return values for accuracy, precision, recall scores, and F1 scores will demonstrate the accuracy in which the data set can be used for future predictions and /or identifying the correct conference league of the running back. The KNN algorithm shows to have better performed to the naive Bayes algorithm in all four categories, which will be seen in the next two slides. KNN can correctly identify more players that are from either conference with the respective conference based off their stats in comparison. It must be noted that it is not truly accurate nor reliable since their values were not close to 1. However, you will see in the next slide they were about a 50-50 chance. So for a visual of what was stated in the last slide are these two confusion matrices. So saying why naive Bayes was not as accurate as KNN would be since we have way more true positives with NFC versus AFC being confused with NFC when we use the naive Bayes algorithm. On the other hand, however, we see that we find more true positives for both AFC and NFC, as AFC has now 5 players that were actually correctly classified as an AFC player, and we also have an increase with NFC players being at 14. So the table is just going to be an overview of more what the actual numbers are for how well each model performed. As you can see, we can stated from previously, KNN did perform better as accuracy is roughly 13% higher than naive Bayes, as well as the precision is way higher as it almost doubles the percentage for naive Bayes.
So in order to wrap up, The things that we addressed here in the PowerPoint were our introduction continuous data set, which was the traffic one, the two models that we used, which was k-mean clustering and multiple linear regression, our categorical fantasy football data set, which involved the k-nearest neighbor, naive Bayes, and the various results. Thank you so much for watching.